I'm Vavuniya, and I'm working as a project consultant for the Constructed Wetland project, which was we have implemented in the coastal area of the this undergraduate faculty, and
staff
so today we will be discussing about the construction wetland, the similar project which we did in the coastal area. So today we are going to talk about the introduction of this concept and how we can apply it for the wastewater treatment, and what are the treatment mechanisms involved in this wetland system, and design details, very basic design details, and what are the maintenance aspects of these constructed wetlands, and similar case studies which we have done in other areas. So these are the basic outline for today's presentation.
ನಾನು ಇಲ್ಲಿ ಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡೋ 6 ವಿಷಯಗಳನ್ನು ಇಸ್ಕೊಟ್ಟಿರೋ ನಾವು ಇಂಟ್ರೊಡಕ್ಷನ್ ಉಂಟು ಕನ್ಸ್ಟ್ರಕ್ಷನ್ ವೆಟ್ಲ್ಯಾಂಡ್
So let me start with the introduction. First we will look at what is the constructed wetland. So it's a man-made system designed and constructed to treat wastewater. Since we are basically focusing on the wastewater, so it is a man-made system to treat the wastewater using the natural processes. So natural processes are basically the combination or interaction between wetland plants, soil and microbial community. So by using plants, soil and microbial community, we do the treatment in the wetlands. So this is the basic simple setup which we can implement for the household type of waste by using a constructed wetland. So liquid effluent which is coming from the household, we can divert it to the wetlands, and from the wetland treated effluent can be used for irrigation. And since we need to reuse the water, so that water can be used for the irrigation purpose. And if there is any excess water, that of course can be run off to a surface water stream as well. And so by using the wetland plants, like we are using cattail type of plants for the wetland, so that can be used for the prepare these mats also. So that's one of the other advantages from the wetland plants. And the basic uses or the advantages of the wetland system is it improves the water quality, including the heavy metals and the pathogens. Pathogens in the sense the bacteria. And low construction cost, cement or concrete, and we can use the bentonite kind of a special soil, or otherwise clay can be used for the two layers. And it is very least maintenance, like no chemical and no or little energy requirements. Energy is only needed for the pumping only if we need it, and less sludge. And it provides natural habitat to the animals, and by using that we can have this cooling, and it's added beneficial system for the environment. So quickly let's go through the main components of the constructed wetland. So first we have the influent where the water wastewater comes in, and second the bedding media which we call as gravel media. Then the wetland plants are there. Then the root zone, very special zone which is with the treatment, and the effluent. So these are the main components of the of our wetland system. So now let's see how we can use this constructed wetland for the wastewater treatment. Types of, when we discuss about the types of wastewater which we can implement this system, of course the domestic grey water which we have done in India as well, and stormwater runoff, and the black water or the toilet waste can also be treated by using the our this wetland system. And basically a wetland system acts as a biofilter, removing sediments and pollutants such as heavy metals also from the waste. And when we discuss about the vegetation, vegetation provides a wetland the substrate which the microorganisms can grow. So the root system of the plant helps the microorganisms to grow inside our media, and they are acting as a major contributors for the pollutant removal process. And so these microorganisms and natural chemical processes are responsible for approximately 90% of the pollutant removal. And we can use different species of plants according to our requirement of the nutrient uptake. So canal, bulrush, cattail kind of very natural growing plants are used for the wetlands. And when we discuss about the types of wetlands, there are different types of constructed wetlands. Based on our need, we can design the system according to our requirement. So this is the mostly used system, subsurface flow, where the water flows inside the soil layer, so that we cannot see an open water surface on this system. Water comes in and goes under the soil layer and goes out. So this system is mostly practiced in the industry. So we have applied the same kind of system to our coastal premises as well. So water comes in and goes inside among the root system of the plants, then get treated within that area, and it gets out from the system. This is subsurface flow. And the next one is the free surface flow, where the water surface is visible. So water flows on top of the soil layer. And so this system has few disadvantages, like in our tropical conditions we have some mosquito breeding can be a problem when we have this open water surface on top of the wetland. But still it is also practiced in the industry. So this is free surface flow. And according to the flow direction, there are two other types. Vertical flow, which means water is poured from the top, and water is flowed vertically downwards and gets out from the system horizontally. And this is horizontal flow, where water comes in horizontally and get out from the horizontal direction. And the floating wetland is a special kind of wetland which we use for open water surfaces like lakes. And to improve the water quality of existing surface water bodies, we can use the floating wetland. So these are the main types of wetland which we can see in the industry. So then I will move into the treatment mechanisms. So when it's come to the solid particles of the wastewater are mainly removed by using this sedimentation and filtration processes. So when we are normally designing a wetland, we are having an inlet and outlet zone. So inlet zone have this filtration process. This inlet zone is focused for the filtration, and when the outlet zone is for the sedimentation. Like so, inlet water get filtered from the filter zone, inlet zone, and it goes through the root zone. Then after that, if there are any sediments which are carried from this middle range, it gets deposited at the final stage from the outer zone, and water can move away from the wetland. Then this oxygen is a main component of these wetland treatment systems. So basically, because of the root zone of the plants, we have an oxygen-rich environment around the root zone. So it we call an aerobic zone around the root zone, which facilitate the aerobic microorganisms around the root. So let's come to the organic matter removal. Organic matter is removed from both these aerobic and anaerobic conditions. Aerobic conditions means where we have lot of oxygen. Anaerobic is where we have less or no oxygen. So those are two different between this aerobic and anaerobic conditions. So organic matter is removed around the root zone by using the aerobic system. So aerobic bacteria are involved. So basically organic matter involves carbohydrate and proteins, CH, O, N, P, those elements. With the use of oxygen and the aerobes or aerobic bacteria, we can convert to carbon dioxide, water and energy. And in the anaerobic zone, or the anaerobic condition zone, where the anaerobic conditions are normally occur at the bottom layers of the wetland, where the roots cannot penetrate area, that is where we have the anaerobic zone. So anaerobic microorganisms develop in that bottom layers. When the organic matter enter into that one, organic matter removal can be occurred in that zone as well. Anaerobic microorganisms can convert into carbon dioxide, methane, and water. When we look at the nitrogen removal, of course, when the organic nitrogen enter into the system, around the root zone, this converted into nitrate and nitrite by using aerobic zone, and benthic zone or below the root zone where the anaerobic conditions are there. In that conditions, the denitrification occurs, and the nitrate and nitrite is converted to N2O, nitrogen gas. And finally, the phosphorus. So phosphorus is one of the main ingredients for the wetland plants, basically for all the plants. So phosphorus is absorbed by the root zone to the plants, and it involved into the growth system of the plants. And so these are the main design requirements. So when we are designing a wetland system, we need to know the total flow of the system. What is the wastewater we are getting? How much of wastewater? And what is the kind of wastewater? What are the influent? What are the influent parameters of the wetland? How polluted is the wastewater, and what are the type of pollutants which we are going to remove, like do we need to focus on organic matter or nitrogen or phosphorus? That is also one thing. And the temperature also matters, so we have to take the temperature also into account, and the porosity of the material, or like we have to fill some material inside the wetland, like soil, gravel. So those material we have to know the porosity. And depth of the material bed, how much would be the depth. So, because normally we are doing the underground construction, so what is the water table of that area, so depth also matters. And this is not a design requirement, but one of the key thing for a successful wetland is we have to minimize the solid entering into the wetland. Although we have a solid filtration system inside the wetland as well, but still it's better to prevent the solids as much as possible. So solid means solid, oil, those things. So always we are advising to have a screen or geese trap or septic tank before the wetland, so that it makes sure the proper functioning of the wetland. Then this is the design equation for the wetland. So this is the basic equation, one of the basic equations, where we have this pollutant concentrations, Ce and C naught, and the hydro retention time and the temperature coefficient. So hydro retention time is the time which this one water droplet come into the system, and how much time it stays inside the system before it gets out. So that is the hydraulic retention time. And this is the again I have described what is the hydraulic retention time, and length and width can be adjusted with the site conditions. We can adjust the site length and width. And when we talk about this Vavuniya campus design, so we have designed the system for 400 students, and that is for the grey water, actually, not for the black water, but for the grey water. And that is design capacity is 45 meter cubes per day, and so we have designed two wetlands, two trenches actually. So one trench gets half of the flow, so 22.5. And type of wetland, subsurface flow wetland, we have designed for the system, and we have targeted these suspended solids and BOD5 removal from the, since those are the major pollutants which is coming from normal grey water from timber. And so this is the temperature variation and the rate variation is rate constant are there, and porosity of the material we have considered as 0.4. So we have taken the depth of the bed is 0.7, and we have kept an additional 0.3 meters on top of the bed so that we can avoid the flooding, and there should be some free space for the maintenance work. So that the depth is 1 meter then. So width of the system was 3.1, and we have kept this HRT as around 27.19 hours, and hydraulic gradient or the gradient of the slope was 1%. So these are the basic design parameters which we have used for this wetland in Vavuniya campus. And let me go through some maintenance aspect of the wetlands. So time to time we have to clean and replace soil and gravel. So normally we are doing like this is normally once in 3 years times. Maybe we have to clean the gravel, we have to take out the gravel, and we have to wash it and fill it back. And the normal routine maintenance work is remove the excess biomass, because plants are growing here. So that once the plants are mature, once the flowers and fruits are there, this plant is mature, so that it cannot take up more nutrition. Normally the plants are taking the nutrition from the water, from our grey water, so that the plants are absorbing the nutrient from the water and it is growing. So time to time when the plants are mature, we have to harvest the plants. Then we have to remove those harvested plants away from the system, and we can use it for the composting. That is why we have mentioned as overgrown plants are not much effective, because when the plants are at the growing stage, it absorbs more pollutant from the water. So we have to cut the plants or harvest the plants when it gets mature. And of course we have to do some regular checkups at the manholes, and if there are any debris are there, we have to remove the debris and check the pipeline for these blocks, and remove that we have to remove if there are any dead or felled leaves. Like if the bed was covered from the leaves, we have to remove those, because we need to take this plant should get the nutrition from the water only, not from the dead material on the bed. It has to be absorbed from the water. So those are the main things which I needed to discuss today, and thank you very much. Yeah, any questions please?